let's write down an example to work it together. Of course, don't forget that today's lesson is just a brainstorming for you, okay? It's just a check for me, to check your understanding and your degree of, understanding the concepts.
Mm-hmm.
So let's say that I'm giving you the circuit like this. This is resistance R1, connected like this with R2 and R3. And at the ends of these circuits, you have the battery connected, having EMF E and R small as internal resistance, okay? And I'm giving you some numbers to work with. Check something over here. So I'm telling you that R2 is 3 ohms, R3 is 6 ohms, R1 is 4, and R small is 2. Following?
Okay.
And E is 40 volts. Let me check the numbers again to make something easier for you. Okay, that's right. Okay, and I'm asking you to find first the equivalent resistance of the whole circuit. Second, the current flowing through the battery. C, the voltage across V2 and V1, across R1 and R2.
Okay.
The terminal voltage and the power delivered to the external circuit.
Okay.
Maybe it looks complicated. You are going to go through this together. Please focus on a typical problem like this, because it incorporates many different things that you must be, I would say, familiar with.
Okay.
So we start with R equivalent. Any ideas about how should I solve it?
Okay. So I would do 4 plus 1/6 plus 1/3.
Let's take it from the very beginning. What is the simplest connection that you have to start with?
The R1.
No, R2 and R3 in parallel.
Okay.
Let's put some points over here. A, B, and C.
Okay.
Current starts from the positive terminal, right? It goes through I1, through R1. So I1 is the same with I, but here it comes to a junction. What is a junction? Can you recall it? Can you remind me what the junction
When
is?
it separates?
The junction is a point.
Mm-hmm.
The wire splits in 2 wires. One part of the current is flowing through R2, we call it I2, and the other one is called I3. And then in the other junction, C, they keep going the initial current, right?
Yeah.
So the simplest circuit that we have to identify is that R2 is in parallel with R3. Do you agree?
Yeah.
So you start with 1 over R of 2 and 3, we label it this way.
Okay.
It's 1 over R2 plus 1 over R3, which gives 1/3 plus 1/6, which gives 1 over 2. You put it upside down.
2.
You get to do this, it's 2 ohms. Following?
Yeah.
Great. And now imagine that this is the equivalent resistance of R2 and 3. And in which way is this connected to the rest of the circuit?
In series.
In series with R1. So I write R1 of 2 and 3 is R1 plus R2 and 3, which gives
6 ohms.
But R equivalent should be all these external resistance plus small internal of the source. Don't ever forget it. So it gives you...
Just sorry, is R equivalent the same as R total?
Yeah.
Okay, so I always put the little r.
Yeah, don't forget it. So the little r, the internal resistance, must always be added to the total external.
Okay.
Don't forget it, except for the case, but we have an ideal battery which gives R equal to 0. Okay,
Okay. So if it doesn't say the little r, then would I assume that it's 0?
no, it must be clear.
Okay.
If the wording of the problem is okay, because sometimes, you know something, don't you ever trust all teachers and all books? We keep doing mistakes. Many times, yeah, I teach physics 28 years and I'm still learning, believe me. So, which means that maybe the wording of the problem is not the perfect one. Maybe there is a missing data. But just in case of a perfect wording, it must be clarified. Okay? So what about part B? It's simple. How should I write the total current? Tell me.
Well, since we know the resistance and we also know the EMF, would we just use I equals V over R?
Which is E over R equivalent. So it is 40 over 8, which gives 5 amps. Really, really simple. And now it comes to the most complicated parts of the problem, C, D, and E. As you can see here, we have V, let's say V1, the voltage across the resistor R1, and we can say V23, and you see here, the voltage across the parallel connected R2 and R3. Okay with this?
Yeah.
I'm asking you to determine both V1 and V2. V2 is equal to V23, is the same thing. Let's label it V23, which is common. What should I write here? How should I think about it?
Well, I'm just guessing that like I can still use the same equation like well, when we're trying to find V, so it would be R times I, but instead of using the R equivalent, we use the R of the individual sections.
Perfect. You are really good. You are really good, but maybe you are kind of I would say you have misunderstandings.
Okay.
With physics is a very common one. Misunderstandings in physics maybe have to do with you, with the book, with the teacher, with the school, whatever. We have to find the reason for misunderstanding. And once we find it, you have nothing to worry about, believe me. But we have, so you have 5 times 4, which gives you, that's all.
Okay.
And in the same way, what should I write about V23?
5 times 2.
It's I times R23, great. It's 5 times 2, perfect. And now let's go to part D. How should I write the terminal voltage?
Okay, well, what I would say is that the voltage, I'm just guessing, but I'm pretty sure the voltage would have to be what it was in the first one.
Take a look. Let's go back here. Can you see what I'm showing you? You take this formula already, just plug in. V terminal is the EMF minus the current flowing through the battery times the internal resistance. You have to use it.
Okay. Well, it's just because we have our formula books and that one isn't there, so I have to learn it.
Yeah, but you're going to be given the formula sheet, you know it.
But I have the book that they're gonna give us, and that one isn't in it.
Of course.
But it's fine. I'll just write it down, so I have to learn it.
Great. No, actually, in my country here in Greece, we don't give any formula sheet, believe it or not, during the national exam. And maybe it sounds strange, but I remember myself as a student at the university many years ago. Don't ask me how many, about 30. And I would say that I remember a professor of ours who came in the classroom one day and said, the next exam will be with open books. And we're really amazed, it was amazing. And we keep laughing, okay, with open books, we are all going to take the greater, mark. We all failed. Can you imagine why? With open books, why could we fail? Because the problem in physics is not given any formulas at all.
Mm-hmm.
The problem in physics is to understand which formula is the perfect one for each different case.
Yeah.
For example, do you know how many formulas there are for current? I can't remember how many. But each time you need another one, and the experience and the degree of understanding is the reason for doing it correctly or not. So this is 40 minus 5 times 2, which gives 30 volts. Got it?
Yeah.
And finally, how should I find the external power dissipated on the external circuit? What do you know about it?
Would it be P equals I squared times R?
Yeah, but which are?
R total. Like,
No,
no.
except for external means everything else except for the battery itself. So it is R1 to 3.
Oh, without the little
Without R, yes.
R. Okay.
So this is really tricky. 5 squared times 6, which gives 150 watts. And just allow me to give you I would say a hint or a remark. The total power in this case, total means everything, the source, the battery together with the external circuit, is E times I, which means 40 times 5. How much? 200 watts.
Okay.
How is this total power distributed? A part of it is dissipated on the battery itself, remember it? So it is 5 squared times 2, which gives 50 watts, and the rest of it goes to the external. Can you see the difference?
Yeah.
But
Okay.
if you add them up, these two added must give total. So the total is equal to the external power plus the internal power on the battery itself. Questions?
No, that's fine.